0.38. That's the drag coefficient, a 1960s sedan achieved, a number some modern hatchbacks still can't beat. 3 cars from that decade reached levels of engineering most manufacturers never matched. None of them sold in serious numbers, and few ever show up in documentaries, but company records explain exactly why. Each explanation is different: a factory that built planes before it built cars, an engine stranded by a government decision, and a team that simply ran out of time before the world caught up. Type your country below, then let's start with the aircraft factory in Sweden. Linköping sits inland, far from any coastline, in a country that spent the 1940s building fighter planes instead of family cars. Saab's engineers came from that aviation background, and it shaped everything about how they approached a sedan. Wind resistance mattered to them in a way it didn't to Detroit or Turin. A plane wastes fuel and range if its shape fights the air. Apply that same obsession to a car roof, and you get something almost nobody else was building in 1960. Records from Saab's early wind tunnel testing describe a process closer to aerospace research than automotive design. Engineers shaped clay models by hand, then reshaped them again after hours inside a tunnel meant for aircraft prototypes, not sedans. 60 small revisions later, the 96's body reached a drag figure competitors wouldn't approach for another 2 decades. Nobody outside the factory walls knew any of this was happening. Saab didn't issue press releases about wind tunnel hours. Aircraft companies rarely explained their engineering to the public, and that habit carried straight into the car division. Safety testing followed a similarly closed process. Company files describe some of the earliest recorded crumple zone experiments in the industry, years before the concept had a name most drivers would recognize. Engineers welded test bodies and drove them into barriers at controlled speeds. Then they measured how the frame absorbed impact instead of transferring it straight to the cabin. A 2-stroke, 3-cylinder engine sat under the hood, a design borrowed loosely from motorcycle thinking, chosen for reliability in brutal Nordic winters rather than raw output. None of this reached a British showroom floor with any fanfare. Marketing at Saab operated on aviation logic. Build something correct, let performance speak for itself, and assume customers would notice. Customers in Sweden did notice. Export markets largely didn't, because nobody translated the engineering into a story worth repeating. A journalist visiting the Linköping plant in 1962 reportedly asked why Saab never advertised its crash results. The answer, according to company lore, was simple. Aircraft manufacturers don't advertise safety margins, they just meet them. That answer explains an entire decade of missed recognition. Rally results told a different story, at least for a while. Erik Karlsson took the 96 through some of the harshest events in Europe, including brutal ice and gravel stages across Scandinavia, and won repeatedly against cars with far larger engines. Spectators who saw a Saab cross a finish line ahead of bigger machines had every reason to ask questions. Few of those questions ever reached the company's own marketing department, because that department barely existed in the way Ford or Volkswagen understood the term. Documents from this period paint a picture of a company allergic to self-promotion, run by people who measured success in wind tunnel numbers, not sales brochures. Engineers who could explain drag coefficients in exacting detail rarely explained themselves to anyone outside the plant. That instinct protected the culture. It also meant an entire generation of drivers across Britain, Germany, and America never learned what Sweden had actually built. Government contracts and military ties made this secrecy worse, not better. Aviation work came with its own rules about what a company could publicly disclose, and some of that caution bled directly into how Saab talked about its cars. A country used to keeping fighter jet specifications quiet wasn't about to start explaining crumple zones to a Detroit journalist. Silence became a habit nobody thought to break. A different country handled its own breakthrough very differently, and the results were considerably messier. There, an engine born on a racetrack ended up stranded by a decision made in a government office, far from any factory floor. Linwood sits on Scotland's west coast, a place with shipyards and steelworks but no history of building engines. Government officials chose that location for Rootes Group's new factory, not because it made engineering sense, but because unemployment there needed solving. A car company doesn't normally get told where to build its plant. In 1960s Britain, facing pressure to spread industrial jobs beyond England, that's exactly what happened to Roots. Design work on the actual car had already gone in a genuinely bold direction. Engineers borrowed a light alloy engine block developed originally for a Coventry Climax racing unit, the kind of technology found in Formula One paddocks, not economy hatchbacks. Aluminum construction meant real weight savings over the cast iron blocks every rival used. A rear-mounted layout gave the car sharp, tossable handling that testers compared favorably to cars costing twice as much. On paper, this looked like Britain's answer to anything coming out of Germany or Italy. Reality inside the Linwood factory told a rougher story. Workers hired locally came from shipbuilding and heavy industry, skilled trades built around riveting steel plate, not machining aluminum to the tight tolerances an overhead cam engine demanded. Training programs existed, but nowhere near enough of them, and nowhere near fast enough. Precision work on an engine block requires a completely different set of instincts than assembling a ship's hull, and nobody had budgeted the years it usually takes to build that instinct from scratch. Distance made everything worse. Component suppliers remained clustered around the Midlands, hundreds of miles south, because that's where Britain's parts industry had always lived. Parts now had to travel the length of the country before reaching a factory building an engine that needed more precision, not less, than anything Roots had attempted before. Delays piled up. Quality checks caught engine blocks with tolerances outside acceptable range, batches that should never have reached an assembly line at all. If you're the type who wants the full, unfiltered story behind cars nobody talks about anymore, subscribing helps this channel keep digging them up. There's a lot more buried in factory records than most people realize. Early reliability numbers reflected every one of those problems. Owners reported overheating, water pump failures, and head gasket issues within the first year of ownership. Exactly the kind of complaints that spread fast through word of mouth in a market where reputation decided everything. None of these flaws came from the original design. Coventry Climax's racing pedigree hadn't changed. What changed was where, and by whom, that design got built. Roots' leadership faced a problem no engineering team could solve on a drafting table. Moving the factory wasn't an option. Government subsidies depended on Linwood staying open, tied directly to the political goal that had placed it there in the first place. Retraining an entire workforce mid-production meant halting output the company couldn't afford to lose. Every path forward collected fresh costs nobody had planned for when the project started. Journalists at the time noticed the contradiction clearly enough. Reviews praised the IMP's handling and its genuinely clever engineering in the same paragraphs that questioned whether any given example would survive its first winter. That split judgment followed the car through its entire production run. Years of genuine engineering merit fighting years of assembly problems nobody at the design stage had caused or could fix from London. Nearly 500,000 IMPs eventually left that factory before production ended, a number that looked respectable next to the investment but nowhere near what Roots needed to recover its costs. A brilliant racing-derived engine built in a place chosen for reasons that had nothing to do with building engines ended up remembered less for its handling than for its head gaskets. One more car deserves this same close look, and its story ends very differently. That one wasn't undone by geography or bureaucracy. It ran out of something far simpler: time. South Bend, Indiana held Studebaker's factory, a company that had built wagons before it built cars, and had spent the early 1960s watching its market share shrink toward nothing. President Sherwood Egbert arrived in 1961 facing numbers that left almost no room to maneuver. Sedans weren't selling, dealers were closing. A completely new model, built and ready within roughly a year, represented the company's last realistic shot at survival. Egbert called designer Raymond Loewy directly, skipping the usual layers of committee approval that normally slowed a project like this to a crawl. Loewy had already shaped Coca-Cola bottles and Air Force One's livery, and now he had weeks, not years, to design an entire car from nothing. He gathered a small team into a rented house in Palm Springs, away from Studebaker's own design department. The group worked round the clock through most of that spring. 40 days later, a full-size clay model existed. Compare that to a typical development cycle running 3 to 5 years across major manufacturers, and the number alone tells most of the story. Constraints shaped every decision that followed. Money was scarce, so the body used fiberglass instead of steel, a material choice that solved a tooling cost problem more than it reflected any grand design philosophy. That same constraint produced a shape with no traditional grille at all, something genuinely unusual for 1962. Alongside a low, wedge-like profile that made contemporary Detroit sedans look a full decade older by comparison. Braking posed its own separate crisis. Studebaker's engineering team knew this car needed to go faster than anything the company had previously built, and existing drum brakes weren't remotely adequate for that job. Front disc brakes became standard equipment, a genuine first for any American production car, arriving on dealership floors years before Detroit's bigger manufacturers considered the same technology worth the added cost. Wind tunnel time was scheduled and paid for despite a budget that barely covered basic tooling. Egbert understood that top speed claims needed real proof, not just a brochure full of adjectives. Andy Granatelli, hired specifically to push the car's limits, took a modified Avanti to the Bonneville Salt Flats in 1962. Records set that week included a sustained run past 168 miles per hour, numbers that stood competitively against cars from manufacturers with budgets many times the size of Studebaker's own. None of this happened by accident, and none of it happened with the resources anyone would normally consider sufficient for the task. Word of these results reached the press quickly, and reviews from that period genuinely praised the car's boldness and outright speed. Sales, unfortunately, told a very different story from the headlines. Production delays plagued the Avanti from its earliest months, largely tied to fiberglass body panels that proved difficult to manufacture at any real volume, without visible quality issues showing up on finished cars. Dealers grew frustrated waiting on inventory that should have been moving off showroom floors within weeks, not months. By late 1963, Studebaker's broader financial situation had become impossible to hide from anyone paying attention. South Bend's main assembly plant closed entirely that December, taking the Avanti's original production rundown with it, barely 18 months after the car had first reached dealers. A team given roughly a year had built something Detroit's giants would have needed 3 to 5 years and far larger budgets to match. Time simply ran out on the company surrounding it before the wider market ever got a real chance to catch up. That single fact makes the Avanti different from almost everything else in this story so far. Nobody buried this car through corporate secrecy, and no government office stranded it in the wrong location. A team of engineers and designers built something genuinely ahead of its moment, gave it everything they had inside an impossible deadline, and still watched the company around it run out of road regardless. Brilliance, on its own, guaranteed nothing. 3 companies, 3 separate reasons the world stopped paying attention: silence, geography, and time. Only one of those causes could have been avoided. The other 2 forgotten cars from this same decade never got their story told properly, until now. Subscribe, and the next hidden engineering marvel arrives before you know it.